Um, I wish to welcome you all again. Please let me know if you can hear me well on the chat, just to make sure that we are all set. You can see me well, you can hear me clearly. Amazing. I can see some feedback from Ihab, from Dipendo, Ankit, Basma. Thank you everyone for your confirmation. Okay, so good afternoon, ladies and gentlemen. Welcome to Energizing MENA Battery Energy Storage Solutions and Technological Advances. This webinar is sponsored by Envision, a world-leading green technology company providing renewable energy system solutions for global enterprises, governments, and institutions. It encompasses three major business sectors: smart wind turbines, energy storage, and green hydrogen solutions. This webinar is also in participation of industry leaders in decarbonization. And in order of appearance, we'll be having speakers from NEOM, Veritas, and ACWA Power. I'll introduce myself. My name is Munif Barakat. I am from SolarAbic, which is the MENA region most visited renewable energy platform dedicated for clean tech technology in the region. If you cannot hear us well, or if your colleagues or friends cannot join us here on Zoom, they can watch the live broadcast on our social media of SolarAbic, and our YouTube channel will have the recording of this right after this webinar, so you can check any part if you missed that during today's session. Before I introduce the topic, I'd like to share a quick video of our sponsor. And I'd love to put that on the screen for 1.5 minutes so you get a better feeling about Envision's solutions in the clean tech sector. I'll be having that on the screen in a moment. I hope that you can see that in a second. So putting it in full screen now. Thank you for watching the video, and thank you Envision Energy for sponsoring today's session. I personally get super excited when I see energy companies sponsoring also sports activities, being part of Formula E racing or football, and that's something that definitely gets them closer to our hearts, not just our minds. I'll start with the topic, to understand the importance of what we'll be talking about today. And please allow 1 or 2 minutes for me to make this quick introduction before I hand over to the first speaker. As the MENA region strives towards ambitious decarbonization goals, with many countries targeting net zero emissions by 2050, the demand for flexible electricity sources is paramount. Definitely, we have all seen Saudi Arabia, for example, having this target of having 50% renewables, 50% gas sources on the Saudi grid by 2030, with Saudi tendering approximately 20 gigawatts of renewables from now till 2027. So renewables will reach approximately 100 or 100 till 130 gigawatts of renewables on the Saudi grid. This definitely creates a new challenge since the penetration rate of renewables increases in the electricity grids, and that is not just in Saudi Arabia. So for all of these changes on today's grids and all of these new cities that we see that are being, let's say, built in order to run 100% on renewable energy, whether it is a city or an industrial city or a factory, and many or islands and many exciting projects that we see in the region that are planned, let's say, and built from the beginning to run renewables. This underscores that the critical need to have robust energy storage solutions to support the grid and energy supply. Today, we are privileged to have Marek Kubik from NEOM and Ghaith Khzai from Veritas Group, who will discuss the current state of energy storage in the MENA region and its future prospects. We'll be starting the session with Marek, and then Ghaith will be closing it as per his request to have the last part. Hi, Marek. We're very happy to have you on board. And are you in Saudi in NEOM?
Yes, I am. That's right.
I'm happy to see you joining us from there today, Marek. I'll still continue just with the quick intro and hand over to you after the polls. Since I want also the audience to know that in the second part we'll be talking about the importance of bankability and reliability for energy storage solutions. Since this technology is relatively new, if we compare it to wind and PV, assessing the bankability and reliability is crucial. And Krunal Patel from ACWA Power will share insights from a developer's perspective on ensuring the financial viability and reliability of BESS projects. And then we'll be moving into the importance of integrating various energy generation sources, including storage and hydrogen facilities, and how this presents a significant challenge. And here comes Envision Energy with its fully integrated solution, and we have Rajender Kasadi that will delve into the technological advancements and integrated systems that make these solutions possible. So buckle up your seatbelt. We'll be going on a very fast drive today because we're covering plenty of aspects within 1 hour. Hope that you find this very informative. I hope you find it educational, because this is what we try to do. The speakers today have prepared very well the content for the session, so you can have a full picture understanding about the importance of energy storage solutions. Now, before I hand over to Marek and you get to know him better, we wish to know our audience a little bit better. I see more than 200 people attending the session today, and we are curious to know, first of all, from what country you joined us today. So you have a poll on the screen, and I'd like to ask the people on Zoom to select from the options that you see on the screen. And if you are watching us on social media, then please write it in a comment under the video. Tell us from what country you join us today. We would love to know the country that you joined us from in order to also customize the content as we move forward. I'll stop the poll on Zoom now, just so we don't spend much time in here. I see that the biggest it's widely spread across many countries. I think 18% yes in UAE, 12% in Saudi Arabia. We have 12% in from Levant countries, Egypt, Sudan, Northern Africa, including Morocco, Iraq, Yemen. I'm very happy to see that we have people from all around the region. And one last question, where we would like to know, what industry do you work in? And there's definitely we know that energy storage topic is a topic that is of interest for many players. It's not just regulators or grid operators or huge developers, but it's also like cities take note of energy storage as a solution, and we've seen many leading cities in the world adopting energy storage as a solution for their peak hours demand and more. And we've seen many factories, businesses working using energy storage behind the meter, which makes it definitely a great choice for to sort out a lot of issues for energy supply. I see also the same wide distribution across the industries. We have 14% developers, 18% EPCs, 12% service providers. Public sector, we're happy to see governmental sector with us here, 10% from that sector. Academia, 14%, and 16% of consultants. So basically, we have everyone here on board today. And I think that's we cannot wish and hope for a better audience to have on board today. So I won't take much longer than that. I'll hand over directly to Dr. Marek Kubik from NEOM to kick off the session. He's the director of the battery energy storage systems in NEOM, and he will be starting with us with the why. Why do we need storage? We planned a session for Mr. Khzai right after him, but we will push it till the end as per his request, and we will move after Marek to Krunal to cover the next topic. So please go ahead, Marek, the floor is yours.
Thank you very much, Monif, and good afternoon to everyone right across the region. I hope you can hear me well. I'm sure I'll be interrupted if I've forgotten to turn off my mic.
Oh, good.
And I saw also in the chat that there are people also tuning in from outside of the region and from around the world. So good morning and good evening if you're from sufficiently far away time zones. So yeah, as Monif introduced, I'm working in NEOM, specifically in ENOA, which I'll introduce in a second, and I'm director of battery energy storage systems in NEOM. So basically responsible for all the grid scale storage activities that are being built inside NEOM. So I'm going to provide a little bit of context setting of essentially why is battery energy storage important, what will we use it for, some of the parameters around that, and really set the scene for some of these technology advances and other trends that we're seeing. So as the vast majority of you are in the region, I expect NEOM doesn't need actually a great deal of introduction, but just to say a quick word on NEOM itself. So NEOM is a region about the size of Belgium in northwest Saudi Arabia. And whereas the wider kingdom, as Monif rightly pointed out in the introduction, is targeting a 50% renewable goal by 2030, NEOM is targeting a 100% renewable energy system. So this is one of the really exciting things about what we're doing and building in the area that I work in for NEOM and for ENOA, which is figuring out how do you build a system entirely powered by renewables, which of course you can't do without storage. And this is 20 years faster than most of the world. Like a lot of the countries around the world are setting net zero goals by 2050. So really, this is world leading to do something at this scale and at this pace. Now, many of you, and for those that are joining from outside the region, may have heard of NEOM in the context of the line. This is one of the giant infrastructure projects, sustainable infrastructure projects that NEOM is doing, but it's one of many. And all of these other parts of NEOM, Oxagon, the industrial city, Trojena, the mountain resort, and so on, are all obviously part of this region and all need power, they need energy, they need water. So that is essentially where ENOA comes in, the part of NEOM that I work within. And ENOA is 100% owned by NEOM, a subsidiary of it. And there are three main divisions covering energy, water, and hydrogen. I sit in that energy team, which is predominantly focused on the power aspects of what we're talking about today, and specifically under the flexibility part of energy. So to set the scene a little bit more, having got the sort of basic introduction out the way, the reason we're doing this here, aside from it being solutions technology the world needs, doing 100% renewable grid at this scale hasn't been done in the world before, and doing it sooner than many places around the world will provide a lot of learnings, potentially the technologies, the solutions that are needed elsewhere in the world, is that it's actually just a really good place to do it. If you're going to build a 100% renewable grid, then NEOM is in a perfect location. The reason for that is if you look at the two most mature and generally lowest cost energy technologies out there, lowest cost of levelized cost of electricity, there's not many places where you have really, really good solar resource and really good wind resource. And the intersection of the two occurs inside inside the NEOM region in particular. I'm hearing someone off mute for a second, so if you could remute, that would be great. And so building essentially a grid powered entirely by these relatively complementary profiles, obviously it's sunnier in the day and it tends to be windier at night, provides a really good baseline for renewable electricity. But of course, you need storage to be able to complete that picture, because you can't have a 100% renewable grid based on variable resources without it. And there are essentially two main challenges that we need to solve in the NEOM context. So one is a stability challenge, and that is building a grid entirely with wind and solar doesn't have the traditional inertia that fossil fuel power plants typically provide. And fortunately, this is one of the challenges that we can address with technology such as batteries. And then the second is the more classical one that everyone thinks about, right, which is the intermittency of and variability of renewable resources and power matching. So changing the demand and supply balance to match. And these are two challenges that batteries are really well placed to address, and specifically lithium-ion based battery storage in the near term for a number of reasons. So first is maturity, and I like to start with maturity because often battery storage is thought of as an immature technology or a new technology class. And it's true, it is a new technology class, relatively speaking. I mean, lithium-ion batteries have been around since the 1980s, but it's really only the last 15 years or so that they've been widely adopted in the grid scale storage context. But what may surprise you, and you may not be aware, is actually that from a power basis, a megawatt basis, lithium-ion is actually about to overtake pumped hydro for installed capacity around the world, and that's expected to happen next year. So we're very, very close to this tipping point now. And the reason I mention this is usually pumped hydro is thought of as the most mature energy storage technology out there. And by volume alone, you can argue now batteries are getting to that point, that there's sufficient volume around the world where they really are a mature technology. The second is versatility. And they've been referred to in a number of ways. Battery storage technology on the grid is a sort of Swiss Army knife option, right? It can do everything from energy shifting to frequency regulation to some of the more interesting applications that are really needed in a 100% renewable grid, which is solving that stability challenge. So providing things like virtual inertia, synthetic inertia is really valuable. And the picture I put up here is actually a European project from Lithuania, where the system is being built as essentially a alternative to transmission infrastructure. And so these are starting to become more novel applications that haven't really been thought about in the past, really using batteries to optimize transmission system networks in a way that that hasn't been possible before, but will be needed in a 100% renewable context. A third reason is speed. It's one of the fastest technology classes to actually permit and deploy. If you compare, for instance, I'll use pumped hydro again as the example because I used it earlier, the typical permitting times for such projects, including all of the environmental permitting and the construction time, is typically around 6 or 7 years. That same timeline for a similar scale BESS might be only 2 years. And the actual deployment phase of the technology is significantly shorter. So I pull out this example here from Singapore, system that was deployed in around 6 months from initial construction to operation. So this speed of construction is very helpful in the pace that we're moving and the speed and agility that we need to move in order to achieve this goal in a relatively short time, considering also that there's a lot of supply and demand steps and uncertainties that need to be managed in that period. And the final reason I want to address is also perhaps a slightly controversial one, because I often hear batteries are expensive. And really, this is a very fast-changing space. So you can see here a chart from Bloomberg showing battery cell costs. So this is not energy storage system costs, but the underlying average LFP cell prices over the last 2 years. And you can see since the beginning of 2023, a huge reduction in the cell price. And this is not a static space. The cost of energy storage technology, specifically batteries, is largely driven by economies of scale. And as those scales increase, the cost is reducing. As the cost is reducing, this is meaning we can do more and more things cost competitively with energy storage. And this next graphic kind of illustrates how fast this change is occurring. So if we look at on the left-hand side where we're kind of at today with levelized cost of storage, you can see a chart that's essentially showing which technology is most economic for a certain cycling profile along the x-axis, and then a certain discharge duration on the y-axis. So today, and this is probably mirroring a lot of experience if those joining the conversation have experience in battery storage, is that most batteries are being built in the 2 to 4 hour range today around the world. And that very much matches the experience here. And for longer duration systems, there are other technologies that are better suited. So pumped hydro, compressed air here, in very, very long duration, seasonal perhaps durations, hydrogen. But as this cost curve continues to decline, and it can decline very rapidly as the economies of scale and the learning rates are adopted, you can see how in just a few years, by 2030, this picture looks rather different. So based on those cost declines, which are different rates for different technologies, and batteries are particularly well suited to continue declining in cost, whereas more mature technologies, for instance, pumped hydro here, have been around a long time and there's not much significant reduction seen. The picture starts to change, and we start to see around the 8 to 10 hour duration become economic for lithium-ion BESS. And that's not to say lithium-ion is the only solution needed to build a renewable grid, but it is a very large part of solving the daily storage challenges, the daily intermittency challenges that you will face building a renewable grid.
Just a 1 minute notification, please, Marek.
Sure. Thanks, Mike. So putting this in NEOM's context, you can very much see this mirrors what we expect as well. So that is in the near term, and this graph is starting in the 2030s, the sort of relative deployment of BESS is in the 4 hour range. But as you get into the 2030s, you start to see these longer duration systems of 8 hours in the black, emerging as dominantly required, and then actually also in the 2040s, even 10 hour duration, right? So the use case that we see is changing over time. So I'll finish with essentially just one quick example of where we see this kind of longer duration need over time emerging. So that is, if you look at a traditional power line, you would build it usually to export from a renewable plant. In this case, you see the solar deployed. You can see it's a 6 gigawatt AC output from the solar plant. And if you build it this way without storage, that power line is only being used 30 to 40% of its actual capacity, and the rest of the time is wasted. If instead you build the same solar, but you only build a 2 gigawatt transmission line, you're saving on 4 gigawatts of transmission. If you put in a battery, essentially to fill in the gap, and then shift the energy to the intervening periods, you end up with a system that is 100% using that transmission line. And after accounting for the additional cost of needing to build the BESS, you're saving very, very significantly on the cost of this high voltage transmission. And so this is one of the really interesting cases that excites me, because we're talking very significant optimizations that can be done in a place like NEOM, where you're building a grid essentially at the same time as you're building the renewable resources. So you're not having to deal with a legacy grid that's already there, but you can optimize the two together. So with that, I'll just finish by saying, I mentioned BESS is only one part of the picture. Hopefully I've illustrated today it's a very big part of the solution, and it can help with both these stability and balancing needs. But it's only one prong of the wider NEOM flexibility strategies, which both encompasses demand side, but also supply side. So in addition to this daily storage need, we also need longer term storage, and we see two different types of that. So one is is pumped hydro for really dealing with very long bulk storage, 10 plus hours today. And then additional longer term security, which I probably don't have time to get into. And very finally, just to stay on the right-hand side, we already have one of the largest BESS projects in the region, 600 megawatt hours in deployment. That's actually part of one of the hydrogen projects. But again, I'm probably out of time, so I'll cede the floor. I'm happy to answer questions on that in the chat if better. So, Monique, back to you.
Thank you, Marek. I appreciate this presentation gives us a very good idea about what you do at Innova. I didn't know all of that, even though we've spoken a lot before that and we met personally recently. I know that there will be questions from the audience. Please send these questions in the Q&A section rather than the chat section, because the chat section is quite busy with all the people attending from the region. And I see a lot of guests. You noted that well, Marek, like we have people also from outside of the region. I see some names from South Africa, from Finland, Spain, Australia. Happy to see you all on board. We'll get back to you, Marek, then in the Q&A section, and we'll be moving to Krunal Patel, the Executive Manager for the Central Technology Services, Best Technology at ACWA Power, and he will help us to better understand the bankability aspect of energy storage, since there's a lot of skepticism from some people to new technologies, and to talk a little bit about the reliability aspect. You're welcome, Krunal. We're very happy to have you again on board. This is always a very positive and informative session when you are present, and we're looking forward to what you prepared for us today.
Thanks, Marek. Hope my voice is clear.
Yes, you're audible.
Yeah, audible. So, okay, thank you. So let me share my screen.
Please.
Okay. Yeah, hope my screen is visible.
Yes, it is.
Yes, so good afternoon and good morning to all of you. Very nice to see you all in this webinar. It really means a lot to us. And okay, so myself, Krunal Patel, I'm working in the renewable industry since like 17 years of experience, having a major span of my career in innovation, R&D areas where we try to build up various solutions for the battery energy storage system. And now I'm currently working as a central technology services head in BESS technology in ACWA Power. So my today's topic is battery energy storage system bankability and reliability. So in continuation with what Dr. Marek is explained, I will try to build furthermore about how the energy storage system can be bankable and make much more reliable, and how we are doing the validation in ACWA Power process. So moving further, just to give us some background about ACWA Power. So ACWA Power is entity having the assets of currently 53.6 gigawatt of renewable energy generation, having 7.6 million per meter cubes per day as a desalinated water plants is currently running. Total 77 assets are currently working under the ACWA Power. And there are 4,000 plus employees working in it. And specifically, if we talk about the battery energy storage system, the 5.1 gigawatt hour of our plants are currently in operational and working in the various countries. ACWA Power is also having around all the assets in total 12 countries, various in various regions, specifically in MENA region. So established in 2004 in Saudi Arabia. So majorly this company is from the Saudi Arabia. Moving to the next slide, the proven track record. So in ACWA Power, we have established the various PV as well as BESS project, which are very remarkable in the various areas like Uzbekistan, Oman, Egypt, UAE, in UAE specifically is world largest CSP plant, that is Noor Energy one. Then Sudher PV IBP, that is also the world's largest and the lowest tariff world's lowest PV tariff in the Saudi Arabia, which is the breaking records of set in 2020. And also the Red Sea project, which is currently working in Saudi Arabia, which is a leading consortium between Red Sea project with 100% renewable energy in the Red Sea region. Now, moving to the next slide. Okay. Now, as we understood about what is the how the battery energy storage system work and what kind of requirement and kind of a storage. But at the same time, I would like to explain here what is the significance of bankability and reliability in battery energy storage system. So I would like to play yes, hope this video is played from your end. Also,
Yes.
yeah, okay. So, yeah, the main purpose to show this the video clip is you can see the how and the battery energy storage system, the container, if it is catch up the fire due to the thermal runaway, what kind of a damage can happen if the in case of the fire happen in case of any module of the battery storage container inside, there may be huge chances of the surrounding of all other containers will get damaged. Here is the case where there was a car parking area. You can imagine how dangerous it is. This fire is required around for the complete extinguishing around 8 hours of continuous effort. There are around 2 containers which are completely damaged, which are besides this, and there is a loss of generation, loss of assets, operator life, and also the lot of risk about this. So now with this, I wanted to prove that, or I wanted to explain much more about the bankability and reliability experiences or how we are following in our company. Specifically in bankability criteria for supplier assessment, there are 4 major pillars we identify. The first important is comprehensive project database and supplier evaluation. Now, the comprehensive project database is we need to understand extensive project database, the experience of the supplier. There has to be the battery energy storage system installed at various places around the world at the very harsh environmental conditions. Second most important criteria is for there has to be the tier 1 suppliers. Now there are many third-party agencies like BNEF, Bloomberg NEF, which can give the list of the tier 1 supplier, in which they go much more in detail about the various aspects for the supplier selection criteria, and they identified the tier 1 rating of the list of the supplier. Second, financial stability and the track record. Now, with respect to the financial stability, there are 2 things is most important. One is bankruptcy or we can say insolvency of a supplier. Now we have to go in depth of understanding about the financial records of the supplier. Then there should not be any no financial distress. The major in financial there should not be any major financial obligations having with the supplier. That is a key bankability indicator for us. The strong financial position needs the better technological innovation support in the development. Further, supplier should invest in various technological advancement And these all are covered under the financial stability and the track records. The third and most important pillar is technological innovation and the quality assurance. So as we all know that this technology is continuously evolving. Day by day we are looking at the new concept, new technology, much more improvement in efficiency, much more improvement in the auxiliary power consumption, better LCOE. Now without a technological advancement, this will not be happen, and that is the most important requirement for any battery energy storage system plant. Fourth important point is market presence and supply chain reliability. Now the supplier should be the global reach, and their supply chains should be established, because as we know that there are various very crucial metals are used to build one battery cell. Apart from that, there has to be strong supply chain. So without a single complete establishment of the supply chain with the various countries, with the various subcontractors or various sub vendors, then this should not be happen, because the scale of the project currently in battery energy storage, in case of the gigawatt hour scale, this is very important to deliver the project within a specific timeline, and that should not be affected by any supply chain related issues. And the final, customer trust and integration capability. So the customer trust is most important. The customer feedback reports, the past project experiences, and the overall system to be integrated, and the overall system synergies to be operated to give to give the output with respect to the expected applications of the battery energy storage system is very crucial for us. So at the last, the power system studies is also one of the criteria which identified, because ultimately we need to supply, we need to connect the utility scale of the project to the grid, and the quality of power is also very important with respect to various grid cores of the countries. Moving further, in case of the essential bankability metrics, there are 5 pillars we identify, where I will not go through in too much of detail, but at least review standards and codes. There are various standards like UL 1741, UL 9540A. Now UL 1741 is a very important standard with respect to the safety performance of the power electronics, that is inverters. UL 9540A is very important with respect to the battery cell. NFPA 855, which is a safety related aspects. NFPA 70, 68, 69. IEEE 1547, very important standards with respect to the connectivity to the grid and requirement to fulfill by the grid, harmonics related studies, and likewise. Apart from that, review of the standards and codes, another important is laboratory testing requirement. So battery abuse testing, there is a component testing, each and every related component, the testing and validation is important. Flammability and degradation. With respect to the additional standard requirement, there has to be laboratory related flammability and degradation testing to be performed at various temperature scale, which can prove the performance of the battery energy storage system plant for around 20 to 25 years. Because as we are seeing that this type of project having a life of around 20-25 years, there should not be the degradation difference between what expected and what committed by the supplier. Apart from that, safety design and modeling, there are various thermal runaway modeling, deflagration analysis. So in deflagration panels installed in every container, in case of internal pressure happen, that deflagration panel should open, and there has to be the proper way of operating of these panels to avoid any malfunctional, as well as to operate during the situation of internal pressure release from the battery cell.
Apart 1 minute notification, Krunal, please.
Yeah, okay. So I will not go through in much detail of all the parameter. Moving further to the parameters that really affect to the reliability of the project. So there are 4 parameters which we identify, like number of cycles, state of charge, life of project, and the throughput output on energy from the battery energy storage system. So with that, one more, which is very important, which is power quality, because as we are we are using all the power electronics equipment is prone to the generation of the harmonics, so it has to be controlled in manner to avoid any damage of the all other equipment which are connected to the grid So these all are the major 4 points which are affected to overall reliability of the plant throughout the life of the project. And yeah, and the final summary, I wanted to summarize like a holistic evaluation of reliable and bankable supplier with respect to their technical performance, their health, financial health, project portfolios, the certification with respect to identifying the customer feedback, supply chain stability, and risk mitigation strategy. With this, I wanted to conclude my slides and my talk on bankability and reliability of the better energy storage system requirements.
Thank you very much, Krunal. I really appreciate this presentation today. It is very much informative, and I see it also have fostered some questions that we have already received about your part, but we will get back to that in the Q&A section to talk about it. Definitely, the bankability of any new technology is a big topic, and definitely companies like ACWA Power who implement renewables in gigawatt scale, they pay a lot of attention to that, and that was very evident in your slides, Krunal. Thank you very much. We'll get back to you.
Thank you.
Okay, so next I'll be moving to Rajender Kasadi, the BESS Technical Director for Asia and Africa markets at Envision Energy, to tell us about the turnkey solutions or the complete solutions, how to integrate multiple technologies into a solution as they do that at Envision Energy. Please, Rajender, we can see your screen. It is in full screen. You may start. Thank you.
Hope you can hear me.
Yes, I can hear you now.
Thank you all for joining the webinar, and thank you, Marek, for the wonderful session on how is doing the wonderful futuristic job, and thank you, Krunal, for explaining on essential elements on the bankability. So in this session, I will try to do a technical deep dive into the power system elements which are impacted by the renewable integration, how energy storage can solve those issues. I know energy storage is one of the elements to solve it from the convention sources. Hope you are going to enjoy the session. Just a little bit introduction about Envision Energy. We are world's biggest or the largest producer of wind turbines to the owning the fastest electric car racing team. Our company focused around wind power turbines as well as energy storage and green hydrogen. And we're also currently building net zero parks. Yeah, this is what Envision do. And we have a company called Envision AESC, which is a energy we manufacture the cells as well. And we have a sister company called Universe. They do the integrated platform like EOS and for the smart grid as well as for the EMS and SCADA systems. And we own our Envision Venture Capital to invest in the startups, which are again related to the renewable energy as well as net zero related works. Yeah, let me jump into the other part. So as we transition from traditional renewable energy sources to, it actually decreases the system inertia. Basically, when you're transitioning to a wind turbine or through a solar PV inverter, there is no electromagnetic decoupling between the grid element and along with your generating element, which is actually causing this reduction in inertia. So what will impact is basically you're going to lose a largest generating unit in the power system. Basically, this insufficient inertia it will cause a risk of rapid frequency drop, potentially causes the instability in the system. And there's going to be a change. The reduced inertia also results in rate of change of frequency rock off. And this actually causes, because the system decreased resistance can intensifies the changes for the rate of frequency change. So how grid can actually respond to this? One of the element is um, securing against the largest loss. Maybe we need to add, or a grid has to get some support like 1 or 2 gigawatt from the external support, maybe ancillary services, or maintaining the rock off within 0.5 hertz per second. Beyond inertia, and one more parameter is like this most renewable energy plants, like even the solar grid interface, uh, solar PV inverters. These are like current controlled converters. This actually leads to a, when they are interconnected with the grid, this actually leads to a lower short circuit level. So the current controlled converters, typically they rely on the pace lock loop control mechanism, the system synchronization. It also depends on the it will actually refer to the fundamental component of the waveform for the voltage reference. So these are the basic drawbacks from the conventional solar inverters. During any fault condition, the suppressed voltage magnitude and potentially distorted waveform, this may lead to the converter falling out the step and having difficulty to catch up. So this also can lead to hunting the behavior where the solar inverter will think like the active or reactive power oscillation loop. So the fault current is also the third point. When you are going with the lower SCL condition, the fault current is a factor associated with the system strength actually. So when we think as a fault current, we think it as a negative way. But in order to work the power system protection to work in a sufficient way, all the traditional sources already contributing the short circuit MVA, the similar way, the conventional system need to already providing it, but whereas we are lagging with the renewable sources like with the solar PV inverters. Going to the next point, in the MENA region, actually, what is the another problem when we are integrating with grid following inverters? With increase in the grid impedance, grid connection impedance, the voltage at the point of connection is often found varying with the renewable current injection, because the larger the plants are connected with the grid. The dynamic interaction on the interaction, it will actually give a stability challenge when you are coupled with more inverter-based resources. The consequence involves when you're connected with the weak grid or with the islander grid, it will causes low short circuit levels, and these grids inherently cripple with maintaining stable voltage and frequency levels. So it will have a significant challenge, technically complex challenge to solve. And one more ideal problem for the MENA region, like we recently seen, like in 2018 in Azerbaijan, there is a grid collapse has happened. It's a grid outage is happened for the country, and it took around like 1 or 2 days to restore the to the normal condition. So it is because of the temperature rise. It is even at the 40-degree temperature, the biggest thermal generator in the country was the thermal boiler fans were having some issue. They failed, and due to that, there was a fire broke out what happened in the thermal plant. It caused the biggest nuisance in the country. So because of the current climatic conditions like overheating of the equipment and increased load conditions, load demand because of the air conditioner usage increment. And also there's a recent flood we saw in the UAE. These are also causing kind of power outages in the region. So these need to be addressed one or way other around. So one of the way the grid can grid need, actually the grid required, it should withstand this adverse condition. At the same time, faster restoration it has to do. So this is what we are trying to solve with the grid forming feature of Envision. So if you see, like when the grid forming PCS is connected with the BESS system, the grid forming PCS actually can offer a synthetic inertia that can be that can be mimic the physical inertial response provided by a synchronous machine. During a frequency disturbance, the voltage angle difference occurs between the voltage difference within the grid forming inverter and the network voltage waveform. So the gap can be actually instantaneously simulated by injecting or absorbing the current from the PCS. So this can be done without any much measurement or any control response. So it will actually act towards to balance the to balance the supply and the demand, as well as restoring the frequency levels. The major the brain behind this, the software element of the grid PCS, which will actually interact with even grid forming to the grid following, even though during the grid following time, it is actually following the frequency levels of the grid. At the same time, when it is switched to the grid forming mode, it has to restore the frequency gradients for the grid forming operation. So it uniquely is a unique requirement. It's a combination of currently you are doing a droop and inertia control at the same time. So this is the this is what Envision is doing.
1 minute notification, please, Rajender.
So the grid scale battery storage system actually provide the capability to deliver the firm and flexibility energy behind the inverter. And it is also grid forming BSS regulates the frequency in the microgrid, and it will also provide the synthetic inertia and act as a frequency governor in droop mode on primary control level. And just to solve the problem of restoration service, like the recent conditions or the adverse weather condition in this MENA region, the sequence, when the restoration sequence will happen in a power system is the once your larger generating unit will be switched on first, later on the network or the transmission system will be energized. Whereas while doing this phenomena, like with the grid forming inverter, it is a voltage controlled source. It will not rely on the PLL loop, like, and it will capable of generating its own voltage reference point. So this will enable grid forming converters to reduce the fault requirement, or maybe it will actually act as the fault contributor in the system while this switching phenomenon is happening to avoid any adverse effect. It will also offer the reactive power control, ability to operate within the damping and the setting time, and also it will maintain when you are restoring from PF mode to UF mode or grid forming mode, the frequency restoration to withstand the droop or deadband settings within that parameter to manage the changes in the power system frequency while actually connecting with the load. So as Envision, like when we offer the solution, maybe for the net zero park or maybe for the wind turbine, or when you're prepping a microgrid kind of conditions with the NEOM applications. So during this, there is a severe study is required. It's more like you have to do some of the EMT electromagnetic transient studies as well as the PSCAT studies for different applications. So it's one of the example is like when you're connected with this 10 turbines with 30% of the capacity of the BESS grid forming BESS system. If there is a sudden outages happen, and the BESS system, grid forming BESS system, in a transient mode, has to take all the current injection, or it has to absorb all the current produced by the wind turbine for a certain period of time. It's kind of a millisecond, 800 milliseconds to 300 milliseconds. So when you do the PSCAD model in the network level, you'll identify how the system is behaving. Based on that, actually, you can actually design the parameters or the set points within the PCS. Also, like the parameters like on the converter protection level and the balanced and unbalanced faults and the voltage and the frequency disturbances and active and reactive power dispatch command. These step changes are simulated while doing this PSCAD model. So Envision, we offer that solutions. And one of the project, like 2 projects we deployed till now, one is in our Odos Net Zero Park, and another one is on Mauritius. There is a solar-based plant with kind of a VPP level. So for
Thank
this
you,
project,
Rajender.
actually,
If you can close in some seconds, please, so we can stay on time.
right.
Thank you.
So the key features for this project, what we offered is more or like to respond to the system conditions like frequency change and the voltage change. And also this project is offering the damp control function, which contributes to the oscillation, damping oscillation within the interconnection, and also seamless switching function for the black start. So these are the practically demonstrated project we have. And maybe the team members or the whole listeners are happy to visit our sites as well. And with this, maybe I will conclude my session.
Thank you. Thank you very much for sharing, Rajender. A lot of informative technical content in here, and I see a lot of questions flowing. I'd like to please ask everyone to stay with us. We'd have to extend the session for approximately 10 minutes. We still have one part to do, and then we'll try to answer as much as possible questions in the end. So after this session from Rajender, I'd like to invite Ghaith Khzai, the Power Utility and Renewables Project Director at Veritas Group. You're welcome, Ghaith.
The video is okay to me, yeah?
Yes, the video is okay, but if you kindly speak louder so we can hear you better because the voice is a bit weak.
Now it's better, the voice?
Yes, yes, please. You may share your screen.
I'm sharing, meanwhile. I can start, everything is clear, yeah?
Yes, oh, we don't see the full screen, we see the other screen actually.
Now it's okay, yeah?
We see the other one. If you swap the screens, please, we see the other screen.
Okay. Now it is swapped. Can you see full screen?
Not yet. I see that it is still the same thing, but if you click on display settings above, and there will be an option to swap screens. So once you do the full screen share.
Now I stop the video. I'm sharing the video again, and I hope full screen appears now.
If you click on display settings above, there's then you could swap the screens, or you can reshare the Zoom. So you stop the Zoom share and then share the other screen, please.
Okay.
Meanwhile, I think we received a lot of questions. We won't be able to answer them all. We'll try to answer a couple of them in the end of the session. And then for the rest, we will follow up with the speakers by email and we'll be reaching out to you with some answer afterwards. The session has gone a little bit longer than planned. I hope that you can remain with us for the coming 10 minutes.
I think now it's okay.
Now you stopped sharing. You're not sharing anything on Zoom. Probably just takes a moment to load.
It's okay now?
We'll wait a little bit because sometimes it just takes a while till we can see your screen. We don't see your screen at all now. If you shared your screen, Ghaith, please stop it and then start sharing again because we don't see your screen.
Okay. Okay, now what about now, Munif?
Yes, now it's perfect. Now it's perfect.
Yes, okay. Bismillah ar-Rahman ar-Rahim. Thank you so much for this valuable invitation, and I would like to thank attendees and speakers, valuable input I heard today from all, and also your good selves, Solar. Actually,
Thank you, Ghaith. If you please just speak louder, because I have some
yeah.
comments that you are a bit far from the microphone.
Actually,
Thank you.
Yeah, okay. Now it's better, the voice, correct?
Yes, please.
Yeah, I will try to make as quick as possible to compensation just a minute. Again, I would like to thank everybody. The topic is very interesting and challenging at the same time. This is why we are gathered around this webinar today. And today, from owner, engineer, and consultant perspective, I will show the different way of the things and how we can develop it. But in the quick, I would like to introduce Bureau Veritas very quickly. We have been established 1828. The company contains thousands of experts. Also, we have too many, alhamdulillah, clients spread in more than 100 countries all around the globe. Here are the technical centers of Bureau Veritas when it comes to battery energy storage system technical and service excellency centers. Those centers of expertise covers entire world, and it has geographical categorization to meet all countries and customers' expectations. Our service portfolio starts from design, permitting. We are making a good aid in procurement, tenders, construction, even asset operation and asset management basis. Nevertheless, we are doing the role of helping each and every type of client, utility, ministries, developers, investors, and EPCs, of course, in addition to local communities whom interested in getting our services. About the selected references, I will skip this to just compensate just a minute. So I have some good references and case studies in the world. I slide it quickly so that we dip into our today topic, which is the distribution grids, battery energy storage systems, demand and feasibility of having battery energy storage system on those distribution grids. Number one, it's really well known, but I will repeat it quickly. We have the BESS usually on domestic level, households and small entities, also commercial and industrial, also utility scale. However, there are two arrangements when it comes to connection point, something behind the meter and something upstream and the front of the meter or on the grid side. However, it's important to inform you, my colleagues, about some benefits of those battery energy storage systems when it comes to distribution grid. Now, actually, the reduction of the curve impact, it's really smoothing and shaping the grid from distribution generation point of view. What I mean, the generation is there by renewable. Battery stored its energy at the night or off-peak time. Today, as we are in the middle of peak, batteries are adjacent to the load. It will discharge directly to the load without heading up important energy from transmission and generation side. Now, actually, it is also an alternative way of massive capex investment of constructing new substations, transmission lines, underground cables, overhead lines, etc. From economic point of view, it's really good to highlight that the optimization of the grid bulk bill paid to transmission companies usually in the peak time, there is what's so-called maximum demand tariff. And in this one, the distribution entities paid a lot to transmission grid as a sort of, I will not say penalty, I will say high tariff scheme. So when distribution companies has a lot of battery energy storage systems all around its grid, and even on utility scale, C&I, domestic, doesn't matter, but it will reduce the imported energy throughout the peak times, which will reduce dramatically and credibly the electricity bill paid from distribution company to transmission company. However, the battery energy storage system, we need to remember that the modern alternative of what's so-called the spinning reserve, when it comes from rotary power plants or fossil fuel power plants, the batteries are solid state reserve. And it has faster response time and it has nearest to the load when it comes to distribution. Now, clients, individual has also benefits because of what's so-called TOU. On purpose, I put today this term TOU, or time of use tariff. When it is activated, I mean after completing of the smart meters projects and AMI projects in distribution grids, it will be possible to activate time of use tariff, which usually take multi-pattern of the day to make multi-tariff. As an example, in the peak time, semi-peak time, there will be expensive tariff. At nights and off-peak time, there will be encouraging tariff, so that if you have battery, you will charge at night and you will discharge at peak time. This will reduce your electricity bill when you are a factory or household or whatsoever of electric load. Now, actually, it's also good when it comes to the term of it is a battery storage. So there are energy storage inside, which means power supply more availability in case of power cut. However, I need to define for you, everybody, the time of use tariff. It is a tariff again, defined as splicing the day or the week or the month into multi-category. Example from our number 16 to our number 20. Maybe this is the maximum demand, the time, and the peak time, or what's so-called the night peak. In this one, maybe if I have good metering system, I can categorize the day each 30 minutes or 15 minutes separately. In this case, I will bill as an electricity company or distribution company in different categories or different tariffs scheme. Why we use TOU? Actually, the basic generation or operation scenario splice the year into 8,760 hours. In those hours, we have peaks, we have off peaks, we have semi peaks, as I said before. The 24 hours has what's so-called duck curve. Those peaks in the duck curve can be smoothed or reduced or shaved by using very proper time of use tariff. And it is actually win-to-win situation, because the individual or client or subscriber reduces his bill and the distribution company itself reduces his back-to-back bill to the transmission company. While we need certain infrastructure to activate and work on time of use, which is very essential for the success of battery energy storage system. We need smart meters, we need head-end systems, we need meters data management, and we need very solid communication network. All this setup named AMI, Advanced Metering Infrastructure. If you have smart meter well connected to your head-end system and meter data management for data mining and automatic billing, you will be able to make time of use tariff. I hope the TOU is clear to everybody. If there are more questions on it, please drop your questions throughout SolarBit. I'll be more than happy as a Veritas to answer your questions. However, from feasibility aspect and the challenges point of view, we have the following when it comes to feasibility. It is really mitigating the medium voltage and low voltage losses, because the power flow will be in the battery. I will not import far away power or energy imported from transmission and generation side. It is nearby to the load center, so the losses will be less. Also, it is adjacent to load center. Also, from cost benefit point of view, I mentioned in the past slide what's so-called maximum demand tariff, which is very high electricity price or energy electricity price. And actually, when it comes to compare maximum demand bill versus the capex and the ROI of this investment of this, you will find it is feasible, and the rate of return will be really fast, maybe below 5 years in many of the cases. From challenges point of view, when it comes to BESS on distribution grid, there are really majority of countries of the world still does not have mature and sufficient regulations, laws, and bylaws. Also, the term round trip losses, which are the losses to charge the battery, then discharge it again, charging and discharging, passing by a transformer and batteries itself, internal losses, cables, whatsoever. It's named round trip losses, and it's reached in many cases more than 14 or 16%, which making it challenging. Of course, the number is only indicative. There are much better numbers and there are much worse numbers too for those losses. From asset lifetime point of view, it is really challenging, and we need to know what to buy and what to procure and what are the quality checks by OEMs to secure longer battery energy storage system lifetime. Operation and maintenance
Just 1 minute notification, please, guys.
Okay. From running cost point of view, also for cooling the battery banks and those things, grid impact from voltage envelope, power quality, short circuit levels, it's really a challenge also. And the know-how is not that spread. Only houses of experience such as Bureau Veritas and many other offices has this experience clearly and nicely. Actually, this is challenging framework model. I will skip it for the sake of time, but I will speak on this very important topic, the electric vehicle as a BESS. We have the concept named vehicle to grid. Maybe we can talk about it more in the questions. And electric vehicle idle time. Also from e-mobility, electric vehicle charging infrastructure, how we can employ it as a BESS source when it comes to public transportation, and what's so-called the statistical modeling method of take benefit of vehicles batteries. However, I have set of recommendation here. Read it, please. And thank you so much for the time. Sorry for exceeding 1 minute.
No worries. Thank you very much, Ghaith, for this content. Definitely, it's very difficult to go through the details in such a short period of time, but at least I think the purpose in here is to provide an idea to the audience and have a feeling about what needs to be considered.
We are available to answer any question, Munif. At any
Perfect.
time, please relay your attendees' questions. In Bureau Veritas, we have too many technical experts who can bring up all the answers.
Great. Thank you very much, Ghaith. I appreciate that. Okay, so getting back to just organizationally, I think now we're 15 minutes late in this session, but we completed the main topics. We will go for some more minutes just to answer the questions that we have, but the main, let's say, part of today's webinar is ready. I'd like to ask my fellow panelists to put on their cameras and join me for the Q&A session, where we're trying to answer at least maybe, let's say, a couple of rounds before we end up the session today. I'll start with you, Marek, since I think you got a good rest, let's say, from the first presentation till now, and there's a lot of questions to you. But let me start from the more technical ones. There is a question for you, like if you consider other technologies apart from lithium-ion batteries. I've seen I'll combine both questions. One person is asking about zinc ion, and the other one is asking about sodium ion. So did you consider these in your, let's say, future projects at NEOM?
Yes, good questions. And the answer is yes. This is the bit I had to rush at the end a little bit, which was talking about the layers of strategy. So I mentioned lithium ion, particularly in the near term, and even as the cost curve comes down, addresses a lot of challenges. But then you still need to deal with multi-day forms of storage. So this is where alternative long duration energy storage comes in. Now in NEOM, we have the topography, we have mountains. So it's quite a good environment for pumped hydro, which is a very mature long duration storage technology. But there are many others, some more novel, some more mature. And one of my sort of colleagues at the different team is responsible for essentially looking at LDES. So that includes a whole suite of different applications, largely looking at that, solving that longer duration space. So I don't have probably time to go into the specifics of those. On sodium ion specifically, that's a more easy direct swap in for lithium ion, right? It's the same electrochemistry. It could essentially be used in the same energy storage systems. The long-term potential of that looks quite attractive because the raw material costs are much lower, a tenth of the amount. I think maybe the shortest answer I can give on this one is actually I wrote a post on LinkedIn about this yesterday. So if you want to follow up on that, I'm happy to do it there because it's, again, these topics are generally too complicated to answer in a soundbite, but I see potential there. It just comes down to a question of timing.
Great. I'm personally a follower of Marek's post on LinkedIn, always posts useful stuff in there about energy storage technology. And I also advise you all to follow him on LinkedIn to learn more about that. I'll move to almost the same question to you, Krunal. So from a developer's perspective, how do you look to the other chemistries of BESS? And then I have a second question for you after that.
Okay, so with respect to developers' perspective, we are looking after a more experience, more the proven technology, which having a better supply chain system, better the executed project around in the gigawatt hour scale, so that with respect to taking the operation, the parameters, the operation capabilities, the supply chain capability, the testing and validation effectively. By looking at all this criteria only, we try to adopt a new battery chemistries. Currently in ACWA Power, we have an innovation department where that department is continuously working on experimenting the prototype scale of the project with the new chemistry. And once it is proven, then only we are going ahead with that kind of chemistry. But yes, ACWA Power is really open to adopt a new technological advancement in this specifically in battery energy storage system.
Mm-hmm. And thank you for that, Krunal. Then I will just this will get me to the second question to you. So we do it at once from Mr. Ashraf, asking so in this preliminary feasibility study that you do, how deep do you go into evaluating the reliability of BESS, and what is your source of information? Like, where do you get this information from at that early stage?
Yeah, so it's a really very challenging, and that day by day we are improving ourselves with respect to identifying the more reliable supplier and more reliability experience from the various projects. But yes, there are a couple of simulations what we adopt. We also believe some of the third party related analysis details. We also propose some of the extra harsh environmental condition test procedure, and we have our own checklist to identify the factory related the routine test as well as the some check parameters during the manufacturing process. So by looking at all this scenario, we try to cover the 360-degree validation check for the to identify the reliability of any battery energy storage system solution.
Thank you, Krunal. I'll move to Rajender then, please. Like I've already answered, I think, one question in the Q&A, but it comes now in a different format from Mr. Werner Vermouth, who asks about a typical question, like if we are all using renewables to these kind of performance guarantees for 20, 30 years. Now, in battery energy storage, this is more complicated since like product typically is not guaranteed for such periods. How do you help your customers, let's say, to plan for a certain capacity by the end of, let's say, the 20 years period, and what is the best way of doing that? And again, this question probably between oversizing versus augmentation, or how do you address that as a supplier?
Yeah, thank you, Manif. So you clearly explained it. It's more like the 20 years life is not a bigger challenge nowadays with a one cycle kind of application. If you're going with higher usage, like a 2 cycle or more than that, if you're trying to do a application, then it's going to be a little bit challenge for the 20 years operation. During that kind of application, what we do, we can try to recommend the replacement strategy. Maybe once the battery reaches the end of the life, we will try to replace the strategy. Or else, if you're trying to maintain the usable capacity, you want to have get at the same level, then even we have to go with the augmentation strategies. But with the current deployment, with even 12,000 cycles we are offering, so it won't be a challenge to the battery can last up to 20 years with one cycle application.
Great. And what warranties do you provide as a supplier in this case? Do you provide how long is the product warranty
So
or
in
the
the
performance warranty?
typical MENA region, the requirements are even varying from 20 to 25 years. Those are the timelines. And as a product warranty, we can give it like standard to 2 to 5 years. It based on the project requirement and the application it will go. But again, there's going to be LTSA contract which can go extend to the till project line guarantees. So again, it properly depend on the project requirement as well as the application. So
Okay, and maybe a follow-up question from me. Like I got curious, like since you provide multiple technologies and you provide that as a complete solution, and probably every component has its own warranty, typical warranty terms, like for product warranty or performance warranty. Do you provide like a kind of a full solution performance guarantee or a warranty? If
yeah,
you
we do
provide
provide
generation
for
plus,
our own components. Yeah, we do our for the own components on the even on the performance level on the contractual for the contracts. So if the component is from the Envision and you are expecting at the point of common coupling, we will do the warranty provided those parameters are agreed between the owner and from the OEM like Envision. So it is
Okay.
quite possible.
Thank you. And Krunal, does this make the developer's life easier when the supplier of coverables of doing that?
Yes. So every supplier have their own strategy to work around, and we also put our requirement very clear in front of them. So accordingly, yes, that is not an issue.
Thank you, Krunal. Okay, I'll move then now just to a bit different topic, and I have to jump now a little bit randomly because of the short time in here. I'd like to ask you, please, Ghaith. There's a question from Mr. Saeed Muhtadi, who asks like, what does energy storage compete with? Or the battery energy storage compete with? Like they're talking about power to X concept. We've also discussed other concepts as well, I think, in our last discussion as well. So what do you see in the market as a solution that could actually do the job of a battery in some cases? I cannot hear you.
Thank you for the valuable question. Actually, I read it and I was eager to take the hand to answer it. Actually, it's really clever question and it's really holistic question too. The good point here, we are not only competing. It's not about word of competing anymore. It's about a word of participating more and more and collaborating with all technologies. We are in the era of digital transformation, in which we need to make a role for each and every available technology. We have surplus of technologies and we have too many setups even for the batteries. So BESS is not only one, maybe it is 10 or 20 or maybe plenty. Some cases it compete when it comes to e-mobility, it compete with biogas and gases and hydrogen in the coming future. In addition, the battery energy storage system, maybe it competes with the tariff itself. I mean, majority of utilities in the world now are transforming to smart grid, smart meters, AMI. So the tariff scheme, TOU, is a competitor with batteries. Without it, battery will not find a role in the distribution grid salute. It will remain restricted only for transmission. But with having TOU, it will give a hand and an aid for the BESS. So the legacy tariff schemes is really competing with BESS. When we have time of use schemes, it will be the partner of BES and so on. So the answer is very wide. It needs a lecture, but in general, I'm attending the question to you in this way. If you need further information, Munif, please go ahead.
Yeah, and I'll be happy also to connect you with the person that asked in case there's a follow-up question. Thank you for that, Ghaith. Thank you. Okay, I'll go to the rest just with the very quick, please, like let's say answers from your side so we can close after 3 minutes. I'll start with you, Marek. I have a question from Jennifer and some others asked about more or less your pipeline in Innova. So like at what pace would you be implementing battery energy storage in NEOM? You're on mute, Marek.
It was bound to happen at some point.
Yeah.
Yeah, so I saw the questions, and just to clarify as well, like, yes, the one that I only very briefly presented at the end, that's the BESS there, 600 megawatt hours, is part of the NEOM Green Hydrogen Company project. So this, you can read about it on, there's a press release on it, but essentially that's part of enabling the essentially a mini off-grid system. PV and wind and storage is helping with the stability and balancing of that, optimizing the electrolyzer, and that's all for export. There are also a lot of, I'm talked here today about grid scale storage, but there are also a lot of distributed storage projects happening. So those are all also separately covered. There's a distributed energy team that is doing those. I'm focused on the grid scale. We haven't announced anything in terms of timelines for next BESS, but I hope the trajectory, at least that I've shared, gives you an idea that it's a very significant amount needed in order to enable a renewable grid. So perhaps I'll leave it at that.
Thank you, Marek. I'll move to Krunal then, please. If you can comment, like putting this NEOM aside, looking to the main grids in Saudi Arabia and the Saudi Electricity Company, or let's say in the UAE, even like with these gigawatts being connected to the grid of solar and wind, and I think Saudi has till now approximately 4 gigawatts of renewables connected, and the plan is to auction like 20 gigawatts per year. So, but we don't see the same pace of announcements of BESS projects on the main grid in Saudi. Do you see that happening any soon? Or do you see also, let me complement that question with, do you see like PV plus storage, let's say, as something that could be tendered in the future, or there is a segregation between generation and storage typically? Or this will continue?
One of this question is to me.
Yes, please. Yeah, Krunal.
Yeah, okay. So definitely there is a lots of advantages with respect to the PV plus BESS by looking at the variability of the power generation from the PV, and when we connect with the BESS, along with that we can have a smooth power generation, and that will be affecting the grid power quality improvement a lot. So by considering all these things, yes, in KSA there will be many chances and huge work we are doing to have a PV plus BESS kind of a project, and to give the more better power quality to stabilize the grid, and to operate at this type of project at good efficiency level. Apart from this region, we are also working for the wind plus BESS type of project in various other regions to identify the benefit, the ramp rate control applications. As we all know that the wind power generation is a very peak generation within very short time, which affect directly the grid stabilization. And we have done lots of study around it, and we identify this kind of a project is also very beneficial. So yes, as of now, I don't have a actual number, but definitely moving further, you can see the upcoming projects from both the PV plus BESS as well as wind plus BESS. Yeah.
Thank you, Krunal. Ghaith, you want to comment on that?
Yeah, from potential in Kingdom of Saudi Arabia of this, Saudi Electricity has a very ambitious plan, and it commenced already. They awarded 500 mega, 1.5 gigawatt hour already, and in the steps of final awarding, even letter of award had been issued before Adha holidays, about 1500 megawatt, 4.5 gigawatt hour on the southern area of Kingdom of Saudi Arabia.
Yeah, thank you, Ghaith, for this update. That's a very important one. Probably didn't make it to the mainstream media.
Yeah. By the way, those are public domain information now.
Yes. Okay. Great. Thank you for sharing that. I see, Rajender, you also answered some questions. We've been typing while we were answering the questions live. Thank you for helping out with that. I think we're half an hour beyond our initial plan, but we should have known probably that this topic would spread into these details and questions. I wish to thank all the attendees today for joining us, and for those that have stayed till now, till the end. I appreciate your time joining us from the region and from very different places. I think it's already nighttime in Australia, and we've seen some people joining from there. For the rest, I wish you a great rest of the day. And my fellow panelists today, you've done an amazing job. I personally learned a lot from you. Very happy to have you on board. One more time to remind the audience with the names: Dr. Marek Kubik, who is the Director of Battery Energy Storage Systems at NEOM; Ghaith Khzai, Power Utility and Renewables Project Director at Bureau Veritas; Krunal Patel, the Executive Director in the Central Technology Services team, BESS Technology at ACWA Power; and Rajender Kasadi, the BESS Technical Director, Asia and Africa Markets at Envision Energy, one of, I believe, the fastest growing energy complete solution provider in the world. Very happy to have you on board. I'm very thankful for Envision Energy for sponsoring this session today and for bringing us together on this occasion. Thank you very much for your time and for all of your inputs, and hopefully we meet on similar discussions soon. Thank you.
Thank you so much. Bye.
Thank you. Thank you so much.
Thank you.
Thank you.